Hello. Now we're going to look at translations. A translation just means where we're going to move all of the points that we're interested in the same way. And this connects to something called a vector. And a vector is just something that has a size. It has a particular, how big it is or how small it is, and it goes in a particular direction. And vectors are an important idea in maths we kind of touch on from time to time. So let's have a look at it here. But the key thing for a translation is there's no twisting around. There's no unusual movement. It moves in a very predictable way. All the points are going to move in the same way. So if we take our triangle here, DFE, and we're going to translate it, we're going to move all of the corners, all of the vertices of our triangle by the translation GH. Well, this little arrow up here is how we know we've got a vector. This tells us that we have a particular direction. So arrows have direction, so that's why the vector symbol is there. We're moving in this direction from G to H. So what is the direction going from G to H? Well, G is here. We go to our diagram. G is here, and H is just straight up here. So how did we go from G to H? Well, we didn't move side to side at all. We just went straight up 1, 2, 3, 4, 5 places. So we just moved from G to H is just going straight up in the Y direction 5 places. And that's all it is. Now we can write that down very specifically because we can find the coordinates of G and H. So let's do it that way as well. So visually we now know what the rule is. We're just going to go up in the Y direction, positive Y direction, 5 spaces. But how would we write that out using coordinates? Well, the point G is at 3, 9. So in the door 3, up the stairs 9. And the point H is in the door 3, up the stairs 14. And what rule gets us from one to the other? So we said that we're going to go by a vector or by a rule. Well, the rule is, how much do I change my x values? Well, I didn't change it at all. I just add 0 if you want to say that. And how much did I change my y values? Well, I added 5 to them. To go from 9 to 14, I'd have to add 5. So this is our rule written out in a way that's useful for more complicated problems. And this will build all the way up through our time in maths, that this is the way we can look at translations. That we start at a particular point, and we're going to go to another one, and that gives us our rule for our vector, for how we're going to move. So let's use this now on our point D, and we'll see how we go. So we start at the point D, which is at in the door 10, up the stairs 8. In the door 10, up the stairs 8. Well, let's use the visual method first. So we know we're just going to walk 5 places up. So we go 1, 2, 3, 4, 5 places up. And that should be our coordinates of the image of D. So we're still talking about images. We've translated up 1, 2, 3, 4, 5 places because that's the rule that we had going from G to H. Now, what does that look like here? Well, we know that the rule should be that we add nothing to our x's and we add 5 to our y's. So our our x's are still going to be 10 for our image of D. And then we are going to add 5 to 8. So we should end up at y is 13. And if we look at the coordinates of our image, we go in the door 10 and up the stairs 13. So our coordinates, and from 10, 8 up to 10, 13, because we know our rule is we just increase our y value by 5. We can do that for our other points as well. So F is at in the door 6, up the stairs 5. And our rule tells us that we are not going to change our x value at all. So you can add 0 or just leave it blank. And we have to add 5 to our y. That's the rule that we figured out here. So we should end up at 6, 10. And if we follow our method here, we start at F and we go 5 places up. 1, 2, 3, 4, 5. And we end up at 10. So that's going to be my F dash, and I can see that that has worked out the same way. And I can do the same thing with E. 1, 2, 3, 4, 5. Brings me up, and that's my image of E under the translation G to H. And I can write that in here. So we can see how it is we translate our points using our vector, our rule. And you can see how all of these points have just been brought straight up 5 places, because that was the rule that we found. That was the vector that we were using to move them. Now, here is where we just need to keep an eye on things. If we are given something like this, we need to be careful about which letter comes first, because we were told here that we were translating from G to H. So we went from G to H. But if we were told that we had the vector HG, well, it has the same letters, but they're in a different order. So I'm starting at H, and I would be going down 5 places. So what effect would that have? Well, we're going to fill this in, and then we're going to come back and do it visually. So we start at H, which is at in the door 3, up the stairs 14, and we drop down to G, which is at in the door 3, up the stairs 9. So we've written that in here. Well, just like last time, because going the same, it's just a vertical line, so our X's don't change, but our Y's now are going to drop by 5, because now we're going in the opposite direction. We're starting up high, we're going down to G. So the same rule is going to apply to all of our points. So we're going to not change the X's, but we're going to drop the Y's, Y coordinates, by 5. So we should end up down at 10, 3, 6, 0. 5 minus 5 is 0. 12, 1. So let's see if that's what happens when we apply our rule. So we start at F, and we are going to, we'll start at D. We'll keep it the same as last time. So we'll start at D, and we are going to expect to end up down at 10, 3. Well, we want to drop 5 places, just like we did for our vector rule. 1, 2, 3, 4, 5. And I end up at 10, 3, as I'd expect. I went down my 5 places. I go down my 5 places for F, and I end up down on the x-axis. I go down my 5 places for E, and I end up at 12, 1, as I expect. I can draw in that diagram. Now what happens if we're given another vector and another triangle? So now we've got our translations here where we either move from H to G or from G to H. Let's look at our third situation here where we have the triangle ABC, and we want to translate on the vector MN. So we're starting at M and going to N, and we know that that matters, that tells us something important. So we go in the door 6 to get to M, and down the stairs -9. So 6 minus 9, and N is at in the door 11, down the stairs -8. So now, what's our rule? Well, we went from 6 to 11, so we added 5 to our x-coordinate, and we added 1. To go from -9 to -8, we would add 1. So this time we have to do something to both our x-coordinate and y-coordinate. And if we look at this on the diagram, we can see that we run across +5, and we run up +1. So we can do this on our diagrams as well, but this setup that we're drawing out here will be very important for more advanced problems. So we must do it this way, but to develop a visual understanding of what we're doing is very important as well. So we really need to do both. So now we've got our rule. Let's write in our coordinates for A, B, and C, and see how our translation is going to move for us. So we have our coordinates written in. A is at in the door -4, down the stairs -3, and so on. And we know our rule, but let's do this visually first for the first one, and then we'll see how it works for our rule. So we expect to run across 5 and run up 1. So we run across 5, 1, 2, 3, 4, 5, and run up 1. So I'm expecting that to be my image of A, so A apostrophe. So the coordinates there are in the door 1, down the stairs -2. Let's see if that's what we get when we apply our rule. So we add 5 and we add 1. So -4 plus 5 is 1, -3e plus 1 is -2, and lo and behold, we end up in the same place. So again, our kind of algebra or number type way of solving the problem and our visual way of solving the problem give us the same answer. They're really the same thing written in different ways. So let's do the same thing now for our rule-based piece here. So we know from our vector, from our rule that we figured out going from m to n, we should add 5 to the x's and add 1 to the y's. So let's do that for both of these. And we end up at -3 plus 5 is 2, and -4, and -1, and -7. So let's do that now. We have B's image should be a 2 minus 4. So in the door 2, down the stairs -4. And C should be at -1. So in the door -1, down the stairs -7. And that's C's image. So we went across, using the same rule, we went across 5 and up 1 from m to n. We went across 5 and up 1 from m to n. That's the rule that we're using. And when we draw in those lines, we can see that the shape hasn't changed. And perhaps we've noticed this pattern with all of these. This looks exactly like the same triangle as we started with. This looks like exactly like the same triangle as we started with. They've just been moved over. So all of the points moving in the same direction in the same way means that the shape doesn't change at all. It just changes position. And that's what we look for when we look for translations. There's no rotation, there's no twisting. It hasn't been reflected through anything really. It's exactly the same shape. It's just going to be moved side to side. And that's what we need for now.